Hello, I'm Ali, the team leader. Our team has worked together to design and build what we consider the fastest car. My colleagues will shortly introduce themselves and explain their roles in the team. As for myself, my job was to mediate between team members and delegate tasks appropriately to reach and accomplish our goals. I took the responsibility to establish and maintain communication between all our members for efficient and effective execution. By consulting my peers in emails and in meetings, I was able to consider and choose the best final decisions each step of the project.
Hi, my name is Zaid, and I am the engineering road mechanical designer. I oversee the production of technical drawings for the manufacture of the car. I work closely with my peers to ensure that the drawing communicates very clearly how to manufacture the car, which includes keeping track of a bill of materials, accurately dimensioning car parts, and visualizing the car assembly. I would communicate the car limitation in place and the design of our car to our propulsion engineering and designer and communication leader.
Hello, my name is Fintan and I was the design and communications leader for our DBC project. During our project, it was my job to design our chassis, how we'd hold our bottle, and I also worked with our mechanical propulsion engineer to incorporate our pulley system and such as that we'd have the least amount of weight for our pulley system to get the fastest car possible. It was also my job to create this short video to show you how we came up with our idea and then how we brought that idea to life working as a team.
Well, my name's Colin and I was the propulsion designer and mechanical designer for the Design Build Compete Challenge. I did all the maths calculations in order so we could design a car that would be able to get the bottle up the hill. Through these calculations I found that our initial gearing systems would not work and we needed to change it. So I tested all the different configurations of the gear system and found the most efficient.
The design evolution of our car came about with a lot of change during the actual building process. Our initial design had so that we had a bent chassis that would support the bottle using two dips. One dip to hold the bottom of the bottle and another dip to hold the top of the bottle. Under this we would have had our motor and our battery pack. Due to a slight underestimation of the size of the battery pack, this ended up not working. The bottle was too big and it did not fit in both windows that we'd cut open. In the end, we ended up using the bottom window to have the bottle slot in and then ended up making a tail-like protrusion at the top for the hook of the bottle to sit into so that the whole thing was secure and would not rattle or move while the car was carrying it. On the topic of weight reduction, our initial idea for weight reduction was to cut off corners and cut out two large windows. The cutting off the corners was a purely aesthetic decision as it made a sleek design for our chassis which was bent in several different ways to give it a more car-like and sleek appearance. For our windows, we had a window cut out so that our belt for our pulleys could go through to our axle quite smoothly without knocking off of anything, and then we had another window cut out for the bottle to sit in. All of this contributed to weight reduction, which in turn would make our car faster and more efficient on the ramp.
To build the car, we had to use several manufacturing techniques. Cutting using a guillotine to cut parts of the main chassis and truss, a hacksaw to cut the axle, and a jigsaw to cut out sections of the chassis. Riveting sheet metal together, we would use at least 2 rivets to join any 2 parts. Drilling to make holes for the reveals, and filling to make edges smooth and shading. A great car was taken to keep safety in a workshop, and of course always sticking to the philosophy of measuring twice and cut once.
We were initially set back in terms of our organization because we had a missing member of our team, who was one of our engineering drawing designers. We worked around this shortage by utilizing CAD technology to make changing designs and producing engineering drawings much easier. Some reconsideration of our timeline was also needed because the timescale to accomplish tasks was drastically changed as our tasks were reassigned. Our designs were heavily reliant on resting the bottle on the backside of the chassis. However, we realized that the tolerances we were working with were not appropriate enough to manufacture our final design. In our last moments, we replaced our saddle design with a scorpion tail. In retrospect, inserting the bottle this way was easier, and the design allowed for ample weight reduction. We were also wanting to use welding for the back trusses. However, we were informed that only mechanical joining was available, using nuts and screws or rivets.
We learned that in engineering, communication is a key, especially in the absence of other members. For this reason, great care must be placed into documenting design, relating tasks, drafting technical specifications in a clear and conscious manner. The design evaluations process and also highlight the importance of sketching, modeling and forming equations to reach solutions. By regarding these principles, we were able to accomplish building this car.
If I was to improve doing this car again, I would more than likely use the same technique for building a chassis, but I would, if possible, rather have all the pieces in front of me so that I could get a better hands-on idea of what I was working with. I myself, when designing the car, did find it very hard to visualize some of the sizes, especially the battery pack, as I had an idea that a battery was small, despite the fact that we were using 9-volt batteries, that it would be much smaller than it was. And when the battery pack was much larger, that caused a snag in a lab, which was fixed eventually. But I believe that had I the pieces in the first place, even the battery pack and the motor, I would have had a much easier time designing a better car that would not have had to have such a tweak in the middle of a workshop. I also believe that given different materials, or I also believe that if I was given I also believe that we could have used different wheels or different pulley ratio system, but we had not calculated for this, and by the time we had finished our car, we had designed it, built it, and our numbers looked correct, so we stuck with them at that point in time. I believe had we pushed on a little further, and had I worked more closely with Cathal, we probably could have come up with a car that went faster or was lighter and therefore would have been that little bit faster.